Our goal today is to identify key angles in the unit circle. Let's warm up by just looking at fractions. Take a look at the image in front of you of these two pies. Let's consider one of these images, like this, to be a single pie, like you're eating a piece of pie. And so if that's a single pie of itself, if I highlight just this guy, what fraction of the pie am I highlighting? Well, I'm highlighting one piece out of 4 pieces, so I'm highlighting 1/4 of the pie. And if I look at this guy and I highlight just, let's see, if I highlight just this guy, well, I've highlighted one piece out of 1, 2, 3, 4, 5, 6. So I've highlighted 1/6 of the pie. Okay, let's take a look at a couple more. If I highlight another piece, well, now I've highlighted 2 pieces out of the 6 pieces, which reduces to 1/3 of the pie. Some of you will see that by counting 1, 2 pieces out of 1, 2, 3, 4, 5, 6. Some of you will sort of squint your eyes and zoom out and see, oh, wait a second, there are these sort of bold lines here, cutting my one pie, again, that's this amount, into 3 equal pieces. And so we've essentially highlighted one of those 3 equal pieces. Some of you are going to jump right to the 1/3. Some of you are going to say that's 2/6. Whichever way you see it is totally fine. You get the same result either way. Okay, let's try a couple more. What if you do this? Let's say we highlight this much. Well, okay, I've highlighted 1, 2, 3 pieces out of 4 pieces, so I've highlighted 3/4 of the pie. What if I've highlighted this? Oops. This time I've highlighted 1, 2, 3, 4, 5, 6, 7 pieces. So 7 out of, if we keep in mind that this is a whole pie, the denominator is always how many pieces make up one whole pie. Well, 6 pieces make up one whole pie. So I've just highlighted 7 out of 6 pieces of the pie. Well, that makes sense. 7 out of 6 is more than 6 out of 6, which is 1. And we've highlighted more than one full pie. So we've highlighted 7/6 of the pie. So where is all of this going? This is all going to help us in the unit circle. We're starting a new unit on trigonometry, which is the study of triangles. And in the study of trig, it's very handy to know some key angles offhand. To know, for example, that this is the angle pi over 2, and this is the angle 5 pi over 3, and so on. So our end goal will be to have this unit circle memorized. The unit circle is the circle whose center is at the origin, right? Its center is right here. It's not like here or plotted here or somewhere else. Its center is at the origin, and the radius is 1 unit, maybe 1 foot or 1 centimeter or something like that. That's why we call it the unit circle. Its radius is 1 unit. And eventually you'll need to know where all these angles are, and very soon you'll need to know where all their coordinate pairs are today. But for today, we're going to focus on these guys. We're not going to focus on degree measure because once you get the hang of it, and it will take a little while, once you get the hang of it, radian measure is actually much faster. So my goal is that you will very quickly be able to say, if I give you, for example, an angle, oh, that's the angle 2 pi over 3. Or if I say, can you plot for me the angle 7 pi over 6? And you'll say, no problem. It looks like this. I do not want you shoving these angle measures into your brain and memorizing them in a meaningless way, because then I think you're going to have a really hard time remembering them. And I want you to remember these for the years to come, because you'll see these in calculus, you'll see them in Calc 2, Calc 3, linear algebra, like they're going to keep cropping up. So our goal today is rather just to make sense of them. So enough of that sort of intimidating diagram. Let's look at our friends, the pictures of pi. If, for example, I highlight this image, and I say, what fraction of the pie have I highlighted? Well, keep in mind that this right here, the angle 180 degrees, is the same thing as the angle 1 pi radian. So all I have to ask myself is, what fraction of pi have I highlighted? Well, if I'm looking at a really skinny piece, that's like looking at this piece over here. I've highlighted one piece out of 1, 2, 3, 4, 5, 6. I've highlighted one piece out of 6, so we call it the angle 1 pi over 6, or pi over 6 for short. I'll label that guy here. Okay, let's look at another one. What if I show you this angle? Well, this is a wider piece. It's a piece that essentially lands halfway between my x and y axes. Well, if I'm going to land halfway between the axes, that's because I'm over here. I've just cut one piece out of 1, 2, 3, 4. So this is 1 pi over 4, a fourth of the way to pi. So we call it the angle pi over 4. Okay, let's take a look at some different ones. What if I highlight this one? Okay, the assumption is that this is always my starting place, and then I'm always traveling counterclockwise. So if I highlight this angle, I could think, well, that's the angle that's going straight up. That's landing on the y-axis. So that would be 1, 2, 3 pi over 6, which reduces to pi over 2. Some of you may have looked at this angle and said, you're halfway to pi. It's just half of pi. Great. Some of you may have said, oh, you landed over here. You're 1, 2 pieces out of 4. That's 2 pi over 4. Either way, you're still going to get to this angle 1 pi over 2. Okay, let's look at a couple others. Let's say you land here. Again, we're always starting here. We're always traveling counterclockwise. If you land here, well, I can see that I landed halfway between the axes, so I can use my blueberry pie diagram to help me count it out, right? I haven't landed closer to the x-axis or closer to the y-axis. I've landed halfway between. So let me use my blueberry diagram. I've gone 1, 2, 3, 4, 5 pieces out of, well, keep in mind the denominator is always how many pieces make up one whole pi. So I'm thinking about this guy, 5 pieces out of 4. So this is the angle 5 pi over 4. Okay, let's look at another one. Let's try, ooh, cool. Let's try this one. We're always starting here. We're always traveling counterclockwise. Okay, well, I could say this is right at the y-axis. This landed me right here. So I landed 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces out of, the denominator is how many make up a whole, so that'd be 9 pieces out of 6. So that's the angle 9 pi over 6, which reduces to 3 pi over 2. Others of you may have counted it out over here. 1, 2, 3, 4, 5, 6. You're saying that 6 pi out of, this time 4 pieces make up a full pi, which again reduces to 3 pi over 2. So either way, we're going to call this the angle 3 pi over 2. Some of you may have even said, well, here's half of the way to pi. Here's another half, that's 1.5 pi's, which is 1.5 pi's, which again is the same thing as 3 pi over 2. For angle measures, you'll notice that the trend is we always write them as a fraction, even if that's called an improper fraction, right? 4 pi over 3 is the same thing as 1.3 pi, but you'll see it called 4 pi over 3. So we will also get in the habit of writing these improper fractions. Okay, let's do maybe a few more and then we'll practice a bit more in class. What if you land here? Well, it's not halfway through an axis, and so we're not going to use the blueberry diagram to help us count it out. We can use the apple diagram. Oh, you landed closer to the y-axis, so that must be here. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 slices of pie out of 6. So 10 pi over 6 reduces to 5 pi over 4. How about one in the second quadrant? What if you landed here? Oh, that's closer to the y-axis, so we must use the apple diagram to help us count it out. Oh, that's 4 pi over 6. That reduces to 2 pi over 3. What if you landed here? Well, that could be because you started here and didn't go anywhere. This could be the angle 0. Or it could mean you went the entire way around, which would be 1, 2, 3, 4, 5, 6, 7, 8 pi over 4. Which reduces to 2 pi. Or you could say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pi over 6. Either way, we would say that's the angle 2 pi.